Okay, so I'd like to introduce Dr. Tom Rondeau from DARPA, and he's going to be talking to us about the Bay Area Hackfest.
Yeah, so once again, we are proving that AV is a DARPA hard problem. So those of you who've been around DARPA for a while may get that. All right, so I'm trying to get to the internet now. Ben, actually, if you're here, can you just throw your laptop up here and get my presentation, because resolution issues. So luckily I have time to riff, and I have enough to riff with, because so we're doing this DARPA Bay Area SDR Hackfest. So when I got to DARPA last year, after I left running the GNU Radio program project, for those of you who don't know me, I've been running that for 6 years. Went to DARPA last year as a program manager to kind of take my ideas for software radio and its kind of national use to a different stage and a different scale. And as part of that, we thought this would be a great time for DARPA to engage on a very different level and different model than we have engaged with before. Typically, DARPA, for the past 60 years of our history, has worked on research through programs. We create a program, we announce it, we take proposals, we fund them, we run a program for a few years, and then amazing technology is birthed and goes from there. About, 13-ish, 14 years ago now, we had the DARPA Grand Challenge. That was the kind of proof of concept of self-driving cars, that the technology was ready and available for that. And, thank you, Ben. And so that was a new model. The challenges were a new model for us to engage, and we just had our last Grand Challenge, the Cyber Grand Challenge, last year at DEF CON, which was pretty amazing to watch. And we've already got our next challenge planned, and the DARPA PM for that one, Paul, is in the back there, for the Spectrum Collaboration Challenge, which hopefully you guys have been following, as it directly affects what we're doing here with software radio and our use of the electromagnetic spectrum. So the Hackfests are kind of a different model of engagement, where we're not talking about long-term projects, long-term contracting, not even really a whole lot of money, but the idea is that given all of the technology and tools and software that we have built collectively as the scientists and engineers that many are present in this room have created, from Linux all the way up to GNU Radio and beyond, those provide a great platform of technology for us to do amazing work in very short amount of time. If you know the tools, if you understand all of the work that's gone into making those tools, this is a way to get technology and innovation done in a different time scale, and that's what we're hoping to look at with a Hackfest. So why am I calling it a Hackfest? This actually goes back to my days in GNU Radio. I started working with GNU Radio in about 2004. I got to know Eric Blossom, who created the project. I was a grad student at the time, and Eric thought that I was at least interesting enough, if not talented enough, to invite me out to a Hackfest in about 2006. And that's where, I think I'd met Matt before, but it was when I first really got to know Matt Edis. First time I got to know Jonathan Corgan. And it's appropriate, although intimidating, to be up here after Phil Karn, but Phil was there too. So let's see, who else? Frank Brickle. Who am I missing? There's somebody else. How could I forget Bob? So these were great ways for us to come together as a community and build both the community and technology simultaneously. And that's a huge part of what we're trying to do here is continue what we, that model of community development, user and technology development that really carried on to when I created GRCon about 7 years ago, to engage the user community in a different way and put the concepts of innovation and quick turn on technology together. So let's take this to DARPA and see what we can do from that platform. And so that's what we're trying to accomplish here, is looking at it from the perspective, okay, what's interesting technology? Phil just talked to you about balloons and a motivator for that. I think he has the credibility that I don't to kind of give why some of the ham radio classic stuff isn't really that exciting to a lot of us. He posed one problem that was pretty exciting. This is it's similar but different. This is a little bit more localized of what do we do when we can put a software radio onto a drone and put it as part of the control link. So the way that I look at software radio is that it is a tool that allows us to program the electromagnetic spectrum. And I think that's a really cool idea, a really powerful idea of taking this force and moving data and moving information across it. So if we can program the electromagnetic spectrum, that is where we start from software radio, and I'm trying to kind of operationalize that or put an application behind it to make it even more exciting and more tangible, more real. So if we look at what we do with drones today, we put on a black box that's a 915 megahertz radio or a 2.4 gigahertz radio. Maybe it's Wi-Fi, but whatever it is, it's a black box. And so everything but the application layer, and many times even the application layer, is blocked off to us. If we're lucky, we have access to the application layer. There's a processor on there, there's an operating system on there, and we can put our applications in there. And so a lot of people have been working on that level of engagement with drones like the 3DR Solo I've got up here. But these show limitations pretty quickly when we're using waveforms and modes and modems that were designed for terrestrial use, for indoor use, for uses not flying a small mobile vehicle in three-dimensional space. So we're going to run into problems. And we saw this problem when DARPA ran a program called the Service Academy Swarm Challenge, where we took the 3 service academies, we gave them code and swarms of fixed-wing and quadcopters, and we said we're going to battle them in a space. So each team could be launching 25 drones simultaneously and having battle tactics to try to do kind of capture the flag scenarios. So Tim Chung, who held the record at the Naval Postgrad School for flying the most number of drones simultaneously, and that was 50. He reached 60 at the Service Academy Swarm Challenge. They ran out of spectrum. That was their flaw. They couldn't, as much as you can do in the application layer, assuming that you can work all the problems out underneath, he still just ran out of spectrum. And so that's an interesting model for us, because if you've been following drones in the DoD, we have a strong interest in swarms and tactics from drones. So how do we take that and look at it from a different perspective? How do we take the spectacle of what Intel can do, where they can fly 500 drones simultaneously? Now, this is not a swarm. This is independently programmed waypoints that each one of those drones has programmed into it, and they meet those. They don't operate as a swarm. But that's where we'd like to go. We'd like to see 500, 1,000 drones being simultaneously controlled, and we're not going to do that unless we can program down to the physical layer. And that is the motivation that I have for looking at the Hackfest as, well, we have software radio, we have the tools to look into this. Let's put this together and motivate people to help us come up with interesting solutions. So if SDR makes a spectrum programmable, adding a drone to it makes that drone part of your computing and programmable surface. And so there's some really cool stuff that we can do from there, and that's what we want to explore at this Hackfest. So the way that I'm doing it is with a 3-part series, I refer to it as. So we've got a hackerspace. This is important to me from the community aspect of what we've done in GNU Radio and other open source projects of I want people to come out, engage with the experts that are going to be there, engage with enthusiasts and people who are looking to create cool technology. And this will be an open, free access for the week we're at NASA Ames to just come and explore and experiment with us and engage that space. Second, what's going on is I've got this pretty incredible speaker series, and listed down there are the 10 speakers that I've got throughout the week, and they're segmented into 5 different days. So I don't want to. I could talk forever about this because I'm super excited about who I've got. But Cory Doctorow is a name many of you may know. Interesting character, challenging character, which is exactly why I want him to be there to give us new ideas for what we can do with the future technology. We've got this guy, Ben Hilburn, who's, whoa. I'm running through the scenarios in my head of how that could have happened. Like, at what stage did my copy and pasting go wrong? All right, well, Bill, Ben Hilburn, talking about SDR. You got Chris Anderson, former managing editor of Wired, now created 3DR and is really involved in the drone space. The Joe Grand and Sammy Kamkar, they may be the most obscure names to this crowd. They're both hackers. We brought them in from the hacker community because if I'm talking about a programmable surface of Spectrum and drones, that is a security nightmare that we're enabling. So let's start to engage that early by talking to folks like this. And then Linda Doyle and Pierre DeVry are two old friends of mine who are fantastic thinkers and speakers about Spectrum and policy and regulation, and are going to give some really interesting ideas for, as Linda says, why have we not disrupted more? With all the technology that we have and can do, where has the disruption actually gone? And so we're going to be talking to those people to motivate new ideas. So that's happening throughout the entire week. And then the last big portion of this is I really did want to have a tech push to the Hackfest. So I opened up a call for participation, got 8 teams that I selected to come and join us and work specifically on some mission problems. So I'm building a problem book that I'm going to hand to them the Monday of the Hackfest. They're going to be prepared with all the software and the hardware and the knowledge of the big picture of what we're trying to do, and now the specific, here's what we want you to try to accomplish this week, shows up Monday morning, and then they're going to work through the entire week to try to make progress on those problems. And then by Friday, they're going to come to a panel of myself and a few other DARPA PMs to analyze their solutions and see what kind of technology that we want to take forward from what they've showed us in like 4.5 days of work. So to do this, we've got the hardware. And this is putting an SDR on a UAV and the SDR on the ground station, so that the control link is what we're studying here. This isn't putting an SDR as a sensor on the drone. It's interfacing the control link to study how we can manage the communications and controls of the drones, not just as a sensor for it. So we're using the commercial kind of almost normal parts that you'd expect us to use. So we are using a 3DR Solo, which, yes, I am aware that they have stopped making the Solos. There are still hundreds of them out there, and they're easy to get. They're quite capable and quite inexpensive, and my tech team has a lot of experience with them, so they were an obvious choice to use for this. Raspberry Pi 3, USERP B200 Mini for the computer, the embedded computer system, and the software radio system. Putting that on top of the drone, and you can come up and look at this. It's under, it's a nice little 3D case that they put together and mounted on the bottom of that drone. So that's our package that we've put on there. And so what we're going to do is try to send flight control packets, the Mavlink protocol, to the Pixhawk flight controller through that SDR link. And then the ground station we've chosen, it's just going to be a computer, a capable laptop with a USERP B210 on the ground station. So every team is going to get one of these to do their work that week. And then we're actually creating some software for this. Like, the idea is, can we take the software frameworks that we have and build interesting solutions? That's great. We can do that. I wanted to give us a little bit of a leg up. I wanted so that people could really get off the ground immediately with some of the software that we've built. So this is a diagram that we put together to explain how we're doing this. So again, we're going to create Mavlink packets, send them into GNU Radio, create a PHY and MAC layer for that, send it to the UAV, decode them, send it to the flight controller. That's the basic path. The PHY and MAC layer that we've chosen is very simple. I call it this is an old Eric Blossom term, and I'm sure he picked it up earlier. It's the stupidest thing that could possibly work. We just really wanted a basic link just to show that the idea is feasible, and that's going to be then part of the challenge is how stupid it is and how can we and where can we go from there. So the other thing that we're going to do is root access to both sides, ground station and the UAV. You can put whatever software you want on there. You can use our code. You can start there. You can use your own code. We're not really picky about that. The two things that I am picky about is you can modify the drone any way you want as long as it passes a pre-flight checklist that we will publish just for safety purposes, and I'm not going to allow any modifications of the flight controller software itself. We want the vanilla PICSOC. Again, that's more for safety reasons than anything. And I am happy to announce that it is now available through the Defense Digital Services, DDS. So code.mil, or if you go to GitHub webpage for the Department of Defense, you can see GRUAS link is now live in public. And that is the implementation that we're providing and giving about 2 months of activity or of time for folks to look at that code, start hacking on it now, start getting to know what we've done, what you want to do from there, and how we can make that even better. So that is now live and available. I'm not going to spend too much time on this. We do have an agenda. There's interesting injections of these talks that I talked about from the speakers. We've got some lightning talks available to folks who want to sign up and give some of their ideas. We've got brainstorming sessions to kind of give ideas of what people are working on throughout the week. And then at the end of the week, we've got the wrap-up and judging. This Hackfest, we are scheduled for November 13th through the 17th of this year, and we are doing this with in partnership with NASA Ames, so we will be on Moffett Field up in Mountain View. We've got their conference center for the hackerspace and the speakers and the team staging area, and we've got what's known as Building 45 for the flight range. So it's an indoor flight test system that's going to be netted off. It's not the most impressive building until you hear that it was where we used to test the lunar lander, and I just think that's pretty cool. So that's all I wanted to say about the Hackfest. I'm willing to take questions in a second, but I also wanted to announce that to come to the Hackfest, it is free, it is open to everybody, but we do ask you to register so that we know who's coming and we can plan ahead appropriately. And registration is now open, so all of this information and the registration can be found on DARPAHackfest.com. So that's all I wanted to say as far as the presentation material is concerned. What we had planned, if we had a resolution higher than 640 by 480, which is, I don't know, Toby, how old is your laptop? Only VGA connectors. Anyway, so we couldn't get the resolution, but what we do have set up is a proof that this GRUAS link is actually working, and that's what we were hoping to show you. And really, the demo, what we were going to show you is like, there's the proof of concept. You can see it's not plugged into anything, ladies and gentlemen. There are no wires between us. But I really actually wanted to show you the spectrum so you could actually see what we were doing and just that proof that this software radio. But on the bottom there is a box that has the SDR in it, and there's a little bit of an antenna there. And Toby's just... there's no props. I'm not going to fly this. You're all safe today. But eventually what we want to be able to do is we can send commands to tell it to lift off, to go up, to go down, left, right. These are very simple commands. We've almost translated the remote control that you would have to physically move a UAS around. That's what we've proven, and then what I want to do is be able to create programs that then do that for us. So now we basically through Linux, the Raspberry Pi, the GNU Radio, the USERP on there, that entire stack is now programmable for us to start exploring that entire space. So if you're interested, if you want to know more, we are having a workshop this afternoon where we will go into a very deep dive into the actual code that is behind the system so that you can get an understanding for our thought process, how we did this, what we're doing, get to know the hardware, get to know the software a little bit more, help us plan for the Hackfest, help us think through it. And so that will be happening. It is the Shell Room this afternoon. And if you refresh, if you're on the webpage program on GRCon, if you refresh the program webpage and you go to the bottom, both my Hackfest for this afternoon, the agenda is now posted there. And just for a little bit of promo, we're having another workshop tomorrow on RF data sets, and that agenda is also now available. So this will help you make a decision what you're going to see when you come out with us, and hopefully you're going to find it exciting for once we actually do put props on here and can fly this around. Now it's this local, tangible, kinetic thing that we are controlling through software radio And I think that's an interesting and exciting solution to really start studying some of the packet data links that we've always wanted to build properly. And I think this is a really interesting motivator to do that right and to study some of the problems of just that space. So hopefully this has given you some motivation. And thank you, Bill, for your time here this morning. Are there any questions?
Thank you, Tom. Do you have any questions for Tom? And actually, Kirby, if you could come up and start getting lavaliered up.
What approaches are they using to improve the spectral reuse to add more drones?
What are we using?
Or you're proposing to use, I guess.
Yeah, I'm not proposing anything. That is, we are giving you a simple narrowband link and keeping it open from there. So you have restrictions from the compute power from it being an onboard Raspberry Pi 3, which is a pretty capable computer on its own right for the power and size that it is. But you are still going to be, there's a compute envelope there that you're going to be limited by. So it'll be interesting, and that plus the bandwidths and capabilities of the radios. I think it'll be an interesting challenge, the constraints that we're putting on the hardware to see what we can actually come up with. And there are solutions out there that others, if you look at, there's about 4 or 5 different protocols that most people use, most of them dealing with some combination of direct sequence spread spectrum and frequency hop spread spectrum, but they're fairly limited if you look at the protocols right now. Any other questions?
What frequency are you using?
Yeah, I get asked that a lot, and honestly, I don't care. What we are going to make a decision about what those frequencies are. We're using USRPs, the B series, so we can go from 50 megahertz to 6 gigahertz. We will be on Moffett Field, which is an active airbase. They control their spectrum. They have given us a do not transmit here mandate, so we will not transmit there. They have done a spectrum sweep for us so that we can see the unallocated spectrum or unused spectrum, and we're going to make a decision. What I expect to do is I'm hoping to find roughly 10 megahertz of spectrum for every team, non-overlapping, probably even non-adjacent channels, so that every team has their 10 megahertz of free and clear and open spectrum, because I don't want teams interfering with each other. I really don't want any dirty tricks being played. Honestly, if we see anybody who's actively jamming, they're like no questions asked. You're going to be removed from the building. But as far as like what that spectrum is, because we're flying indoors, we don't, the propagation, there are propagation issues, but it's not like we're going to be distance limited or power limited from the distances we're proving here. If we take the ideas any further, that becomes an interesting conversation for what those scenarios look like and what frequencies we'll have to actually look at from there. But software radio, in many ways, makes us not have to care that much about it, and now we just have to look at the physics of the propagation environments and what we can put on for the front ends to specialize for it. So for the Hackfest, we don't really care.
Yeah, as far as managing the spectrum strategy, are you restricting if it's going to be centralized or distributed solutions, or it's flexible there?
That's going to be flexible and I have to be very cagey about how I answer because I'm not giving away any of what the missions that I'm going to ask folks for, because we don't want any pre-planning of this or pre-solutions. But I will tell you that as soon as you see the problem book, some of those answers will solidify themselves pretty quickly in people's minds. But that's the best I can do right now.
Do you anticipate on the laptop something like an NVIDIA GPU?
On the laptop, Toby, where'd Toby go? Yes.
Okay, so we can do machine intelligence.
Yes. Yep. And that's a good point. So an interesting pivot from that question. The teams have been chosen. So they and most of them are represented here within this audience. There's at least one representative from almost every team here. So those are the ones that are going to be focused on the problems. But I am encouraging and hoping that other people who show up engage those missions themselves and start looking at this code from very different perspectives and just using this as a motivator. They're just the teams that are focused on it, but I think that it'll be interesting to see what other people bring to the table for their solution sets too. Cool. Love to see it. Absolutely. Anything else? All right.
All right, thank you, Tom.
Thank you.